many websites, the user interface is able to filter data. For example, in the Find a Law Tutor area of my website, you can use the select boxes to filter by law level, for example, postgraduate or undergraduate, and institution, and that's the particular school at which someone studied law. This is made possible by the fact that each of these fields in the database, each of these columns, contains a limited number of values, and these values are cohesive in meaning. This is something achieved through database constraints. To show you a situation where filters won't work, let me inspect a different part of my codebase, the subjects table. You can see within this schema that it has a grade field, which is varchar, and that there are no database constraints on it. There are also no Ruby land constraints on it either. Let's inspect what the values are by grouping by grade and counting the number of entries in each of these groupings. You can see at the top here that there are many different ways of denoting high grades. For example, an A, first class, distinction, and so on. This is no good for filtering. If I scroll all the way down, you'll see that there's a very long tail with many entries having only one occurrence in the database. There is a total of 265 possible ways to represent grade in my system. This would be relatively annoying to fix at this point, but not impossible since there are only 265 rows. However, it would have been better if I'd enforced some sort of database constraint or even Ruby level constraints to ensure that these fell into a narrow set of categories, which would then enable me to better filter the data. If I bring up the subject model here in Rails, I can add a Rails level validation on the grade column to ensure that it's included within this kind of enum, this set of values. It's useful to have the Rails validation as well as the database validation. That's because the Rails validation will give prettier error messages instead of something like constraint failed in the database, which isn't really something you can show to an end user. When you start off a project or a feature, you tend to have less validations in your model because there are edge cases you haven't thought of yet, or it's simply unfinished. Here, for example, I just have 3 validations, the presence of each of these 3 fields. And then with time, I've copied and pasted them back in. There are other fields like a citation should be there. It should be unique within the scope of a given year. There should be a slug. There should be a year as a separate field. There should be law disciplines. There also should be a validation that content is present, a custom validation in the Ruby world. Now, these were added after I had some law cases in the database. However, these validations only get run when you save or create a law case. Therefore, it's very possible that the old law cases in the database would not validate with the new validations. And this can lead to all sorts of confusing problems. What makes these problems even worse is that the validation might fail at a completely different time to when someone is entering the data. For example, when the timestamp on a law case is touched in order to invalidate some cache. You wouldn't expect that to create a validation error. Rather, you'd expect the validation error to happen when someone is editing them in the admin area. This problem wouldn't happen with the equivalent of validations in a database, a constraint, because the constraint must be true for every row in order to be created. However, some of these validations, or at least one of these validations, doesn't really make sense in the database only world since it's a custom Ruby one, this one of content being present. In order to tackle this problem, I created a sort of task that's run on a scheduler to validate all the data from the Ruby world. Code you see here isn't exactly what I have. What I have is more messy and complicated, but this is a clear version that captures the essence of what's going on. Basically, I cycle through all the classes, all the records in my database, and then run the valid check on them, and then output whichever ones have errors. This helps me ensure that my data is valid according to my own rules going forward. It also makes me realize if I've added a validation too eagerly, something that I'm not able to actually fulfill given the current gaps in my data and whatnot. The biggest regret I have in terms of database design for Oxbridge Notes was a structure that I thankfully no longer have. Essentially, this involved me syncing data from one object to another, i.e. duplicating data. So the structure at the time was that a seller had many notes packs. Notes pack represents basically something you studied, like law or history. Then a notes pack had many subjects. This represents maybe a submodule, for example, contract law or constitutional law. A subject also could be converted into a product. Therefore, there was a relationship between a subject and a product. A subject had one product. In order to build these products, I had the code you see here that sets the institution level, for example, to the notes pack level, its institution to the notes pack institution. Oh, that's weird. There's a mistake here in this version of the code. Then that product discipline should probably be notes pack discipline, and then product state to subject.notespack.state, and so on. Why did I do this? Well, I think I was just scared of join operations at the time, and I was worried about the complication of fetching the subject. This led to an ungodly number of confusions and bugs. Basically because there were so many ways for the underlying subject to change, and some of them did not cause the related product to change in the expected way. Syncing data between two tables is really annoying and requires such a painstaking effort towards detail. I ended up coming up with this class, synchronized product service, that would be called anytime there was a change to a subject. And you can see that the code updates the product grade, the exam year description, and so on, and then reassigns taxons according to the new information, all that kind of stuff. This method then gets called within the admin notespack controller, which you're seeing here, the update method in particular. And this is a bug, one of the bugs that caused me issues. It does not get called when the seller, the author, changes their notespack. This was just an oversight. I guess I added the feature when I noticed a problem in admin, but I failed to think about what happened with the original authors when they wanted to change things. This is no longer the case. I've now rewritten things such that a product delegates name, exam year, grade, description, a bunch of stuff to the subject. This means that the product table no longer contains this information, so my overall database has less columns, always a win. And on top of that, there is no longer any synchronization problem to deal with. The cost for this is that whenever I look up a product, I should also remember to look up the associated subject or subjects, as is the case here. Otherwise, there's a risk of n+1 queries in the view whenever some field that's delegated to the subject is called. I assume most viewers are familiar with the normal use of database transactions to prevent state from being somehow inconsistent, for one part of an operation to be executed, but for the other one not to be, for example, because of a crash. The classic use case is often in banking, where I might withdraw €100 and then deposit it to Mary, but imagine there's a crash at the point after I've withdrawn, but before it arrives in Mary's bank, then that money is lost forever, so to speak. This, of course, can be avoided by wrapping the whole set of operations in a database transaction, such that either they all execute or none of them execute. Here I have some code in order to build up a product on my consumer-facing part of the website based on some data that an author uploads. I've got it all wrapped in a transaction. This is because a product has some associated records, for example, taxons that get created based on the product's discipline name and the institution at which they studied, and then some sort of pivot records that assign those either existing or newly created taxons to the product. It doesn't make sense, however, for some of this work to get done without the other, so there's atomicity. Moreover, this job, along with many other things in my codebase, happens asynchronously in a background job. I want these background jobs to be idempotent in case there's some sort of transient error. Maybe, for example, in extracting full text to Elasticsearch. If I allow some of these records to continue existing, I'd have to rewrite the code and replace any calls to create X with find or create X. Rather than do that in every single location where I'm potentially creating a record, it's easier for me to just wrap the whole lot in a transaction such that everything gets deleted if nothing gets created. That means all this state modifying code can be run again. I basically get idempotency for free. You can also use database constraints to ensure that child records are removed whenever their parent records are removed. The idea being that we get rid of any sort of records that don't make sense on their own. For example, I have a pivot table here, products taxons, that connects product IDs to taxon IDs and enables a many-to-many connection. Now let's say I wanted to delete some arbitrary taxon. I'm going to go for this one here, 148. So I'm going to delete from taxons where ID is equal to that, and we get this error. Key ID 148 is still referenced from table products taxons. I don't really want this. This is the default behavior of a foreign key constraint. It's called restrict, but in this case, I'd rather it just deleted that entry in the products taxons table instead of preventing me from deleting the overarching taxon. The way for me to do that is to add an on-cascade foreign key constraint. What I'm going to do first is drop the current constraint because that is a foreign key one, but not on-cascade. So let's have a look. Taxons. That's products taxons. All right, I've dropped that one. Now I'm going to add another one, and let's have a look at this one. So alter table products taxons, add constraint, fkey 480, sounds references. Let's have a look at this one. This is basically what I had before. Now I just add a bit more on delete Cascade. And now this constraint has been added. Let me go back and run that piece of code again where I try to delete from taxons where ID is 148. Before I do that, let me pull up the products taxons table and show you that this particular taxons ID is in fact being used. Here you can see there are 24 pairings. Now I'm going to drop just the taxon. Drop from taxons where ID equals 148. What have I done wrong here? Oh, yeah, sorry. It's always delete from. And okay, I've deleted it from the taxons table. What's going on in the products taxons table? None found. As you can see, the delete cascaded through and prevented me from having to think about this at any later stage. Well, that's all I've got time to discuss today. See you next time.